Hey guys, welcome back to Geometry Summer Prep. We're going to continue our lesson today over classifying triangles. So let's take a look at our note sheet here and let's dive in. So if you notice on the screen, we have two different ways of classifying triangles. We have classifying triangles based on its angle measurements, and we also have classifying triangles based on its side lengths. Okay, so we're going to look at the two different ways, and then on the other side of this, we'll look at actually solving some triangle types of problems. Okay, let's first classify triangles based on their angles. So you might see some words here that you are familiar with, maybe like acute and obtuse, maybe right. We did talk a little bit about this in our last lesson. So let's take a look at what, if you have a triangle that has three acute angles, what we call that triangle. And it's not rocket science. If it has three acute angles, it's called an acute triangle. Let's write that, and then let's talk a little bit about what acute means. So acute, we'll draw a triangle. We'll say acute triangle. So an acute angle is an angle that measures less than 90 degrees. If you want to make a little note of that, we'll say in parentheses right here, less than 90 degrees. So that is just like an acute angle, okay? Now, if you have a triangle where all three of them are less than 90 degrees, we call it an acute triangle. Okay, we also have something called an obtuse triangle. Let's go ahead and write that here. Let's stay consistent. Okay, an obtuse triangle. Now, if you notice the difference over here, this one has to have three acute angles for it to be an acute triangle. This triangle just has to have one obtuse angle, and then it's considered an obtuse triangle. And let's talk about that word obtuse. You may have seen this before. An obtuse angle is one that is greater than 90 degrees. Greater than 90 degrees. And if you think about it, there's no way you could actually have three obtuse angles in a triangle. You could like try to draw one, but it's not possible. So an obtuse triangle, don't get tripped up here, because it does have two acute angles, but it doesn't have three of them. So it's not an acute triangle. All it has to have is just one really big angle, one that's greater than 90, for it to be classified as an obtuse triangle. Okay, this one I think you're familiar with because we've already talked about this. If you have just one right angle, which is a 90-degree angle, you could say one right angle, that's just 90 degrees. Doesn't matter what the other two are, like obviously these two would both be acute, but if there's one 90-degree angle, we call it a right triangle. And those are the three basic ones. We do have kind of a fourth category here. If you zoom in here, it says if you have three congruent angles. Remember, congruent just means they have the same measure. So you'll notice that by these little tick marks. They kind of have, or not tick marks, but kind of arc marks. That this means these are all the same measure because they all are marked with that same little curve. Okay, so three congruent angles. Technically, it would be an acute triangle, but because they're all not just acute, they're also the same, we have a more specific name, and it's weird, but it's called an equiangular triangle, like equal angles, so you write it like this. It's a weird word, I know. Equiangular. Angular triangle. It's a tough one to say if you're just seeing it for the first time. Equiangular, equal angles. All right, so let's go ahead and try some problems based off of this. So in this section here, it says classify each triangle in the diagram below by its angles. So we're basically going to look at each of these triangles, and there's a whole bunch of them over here. So we've got to make sure we're looking at the correct ones they're giving us. And we're going to list off one of these names for each triangle. So if you look at number one, it says triangle CDE. Now you want to locate those vertices, we would call them, those points, C, D, and E. So let's see over here. If we look at point C, D, and E, so the triangle that's formed by those 3 points, you can clearly see it. I'll kind of outline it here. C, D, E, and you want to decide what type of triangle is that. Well, I noticed right away I have this right angle here, so this for sure is a right triangle. So we will say this one is a right triangle. Okay, let's look at our next one. We have triangle BCE. Let's make sure we're carefully locating the correct one. BCE. So here's B, here's C, here's E. Okay, so if I kind of outline it, let's take a look at its angles. Well, there's no right angles in it. Okay, they're not all the same measure. I definitely have one large angle right here that's clearly bigger than 90 degrees, which would automatically make this triangle be obtuse. So this one is an obtuse triangle. All right, check out number 3. We have triangle ABE. Let's carefully locate it, make sure we're looking at the right one. ABE. Here's A, here's B, here's E. This one's kind of obvious here because we have an example above that's just like it. So we can see all the angles are the same. You could technically give it 2 names. You could say it's an acute triangle, but more specifically, because it marks all the angles congruent to each other, we would say equiangular. Equiangular triangle. All right, number 4, we have triangle BDE. Let's check it out. Let me get my tool here. Okay, BDE. So here's B, here's D, here's E. So let's see the triangle formed by those 3 points. If I carefully outline it. Now be careful here. You do see a right angle in here, but it's actually bigger than the right angle, right? The right angle goes from here to here. We're talking about the angle all the way over here past the right angle. So if it's past the 90-degree angle, this is definitely going to be obtuse. Obtuse triangle. Okay, last one in this section, triangle CFE. CFE. Okay, this little guy over here. And again, be really careful because you do see a 90-degree angle, but that goes outside of this triangle. So be careful when we're looking at this one. This angle would actually be smaller than that 90-degree angle, okay? And these ones over here appear to be less than 90 degrees also. You might have to kind of flip around like the way you look at your paper, but this one would definitely be an acute triangle. All right, so that is classifying triangles based on their angle measurements. Now we're going to look at another way to classify them, and that's by looking at their side lengths. And it's going to have a whole set of different vocab here. These ones, you may have heard some of these words before also, so this could be a little bit of a review. We only have 3 categories here, not 4, so it's a little simpler. So if we want to classify the triangles based on its side lengths, this first one here, if you have 3 congruent side lengths, so again, we're not worried about the angles anymore on these ones, we're just looking at their sides. And the way that you'll know that they're congruent is they'll give you like maybe 3 tick marks like this. And if they all match each other, then they're all congruent. And we call this an equilateral triangle. That's probably the one you're more familiar with over equiangular. This is called equilateral. Equilateral triangle. All sides are equal basically, or congruent technically. But really the same meaning. Okay, you could have 2 congruent sides. Instead of all 3, just 2 of them are the same. We call this an isosceles triangle. And just be careful with the spelling. This one can be challenging. It looks like isosceles. It's a little weird. Isosceles triangle, 2 sides are congruent. Okay, great. And then we could have a triangle where all the sides are different. There's no congruent sides. So this is called a scalene triangle. Scalene triangle. No sides are congruent. And that's really the only combinations you can have with when it comes to side lengths. Okay, so let's practice some of these ones here. Okay, number 6, 7, and 8. They're all based off of these triangles off to the side. So it says classify each triangle in the diagram below by its sides specifically. So this is our word bank here. Triangle JKM, let's locate it. So JKM, here's J, here's K, here's M, if you want to kind of highlight that. JKM, or at least highlight it in your mind if it's hard to do on your paper. Now JKM doesn't look like it has any sides the same. You do see these little tick marks like here and here, but that's talking about this side and this side, right? If I'm comparing this side and this whole side, those are definitely not the same, okay? And then this side over here doesn't mark it congruent to either of the others. So this would be one where none are congruent, which would be a scalene triangle. Okay, number 7, we have triangle KLN. Let's take a look at it. KLN. Okay, so look at the markings on that one. I can highlight it. I don't want to cover anything up though. Notice you have 2 sides marked the same. Let me uncover that actually. Here's my dots. You've got a set of a pair of tick marks here and a pair here, which means those 2 sides are congruent to each other. The one that has a single tick mark means it's not the same as those ones, okay? So these 2 sides are congruent, which means this is going to be our isosceles triangle. 2 sides congruent. Isosceles triangle. Okay, last one in this section. We got triangle JKN. Let's locate that one. So J to K to N, this one's a little obvious, yeah? And we've got one word left to use, but it does mark all 3 sides congruent, so this is our equilateral triangle. Equilateral. Fun little side note, if it's equilateral, it is also equiangular, and vice versa. So if all the sides are congruent, all the angles will also be congruent. And it goes both ways too. Just a little side note there to help you out in the future. Okay, on this section, it wants us to classify each triangle by its angles and sides. So we're gonna list like 2 vocab words for each one. Okay, so one of our words will be from this little set and the other word will be from this set. And we're gonna do it for each one of them. If you wanna try these and like pause it, speed up, check your answers, go for it. Okay, this first one, number 9, let's first classify it by its angles. Well, it does have a right angle, so we know right away this is a right triangle. I'm just gonna say, right, comma, instead of writing triangle, and then say the other word. Okay, now if we look at just its side lengths, we do notice we have 2 congruent sides. So this is also isosceles. So this triangle is both right and isosceles. Okay, number 10. Based on its angles, look at this one they give us. They actually give us the angle measurement, and it is greater than 90 degrees, 114, so we know this is obtuse. So obtuse, and let's talk about its side lengths. Now, this is a little tricky, because if you look at number 10, you might want to go like this and be like, wait, these are the same, because they really, really look like they are. Be very careful with that, guys. In geometry, you have to be able to prove something like that, okay? You can't just assume something like that. You can't assume that sides are congruent unless they mark it or tell you in the description that that's the case. So as far as we know, none of the sides are congruent because they don't tell us that any are. So we would say this is actually scalene. With our given information, it's scalene. No sides are congruent that we know of. Okay, and then number 11, let's take a look at the angles. We have 3 acute angles, so it is an acute triangle, but they're also all congruent. 60 degrees, 60 degrees, 60 degrees. So we would actually more specifically classify this as equiangular. Angular, which means it's going to be equilateral, because I just told you that. So, and they do tell you 7, 7, and 7, they're all the same. So it's also equilateral. Equilateral. Okay, great. That takes care of all of the classifying if you want to go to the practice sheet and just try that part. But we're going to go ahead and move on to the actual solving portion of today. All right, now this is some important stuff you guys are going to use this whole year. You guys end up having like 4 whole units or something like that over triangles alone. And so much of those triangle units are based off of this big theorem right here. And this is actually a really easy one, and you might actually know this one already. It's called the triangle angle sum theorem. Angle sum meaning like adding them together. Okay, now the theorem says the sum of the measures of the angles of a triangle is 180 degrees. Now, there's a whole proof behind this that your teacher may go into. Hopefully they do, because it's an interesting proof. But I'm not here to prove this to you. I'm here to show it to you and then show you how to use it. So this is true for any triangle in the world. As long as it forms a triangle, all the angles will always add up to 180 degrees. Okay, so more specifically here in this triangle ABC, it says the measure of angle A, that's what that little M means, plus the measure of angle B, plus the measure of angle C, all equals 180 degrees. And that is something you want to memorize right now and forever if you didn't already have that memorized. That will help you solve so many problems in the future. Okay, now I debated whether to give y'all this second theorem, but it is very helpful if you know it, so I thought, why not? They can handle it. This is something called the exterior angle theorem with triangles. So let's read through what an exterior angle is first off. It says, an exterior angle is formed by extending any side of the triangle. So taking a look at this picture here, you have a triangle, and then they extended one side, creating this angle on the outside of the triangle. That is known as an exterior angle. And you can do this by extending any sides of any triangles. I mean, I could have extended it this way and been like, here's an exterior angle. I could have extended this side and been like, here's an exterior angle. Okay, so as long as you extend one of the sides, you create an angle on the outside. Okay, now there is a theorem about the measure of that exterior angle. And this one may be a little less intuitive at first, and there is a proof behind it. But again, I'm not going to get into the proof, but I am going to show you what the theorem says. So it says an exterior angle is always equal to, and this is kind of wordy, but it's always equal to the sum of the two non-adjacent interior angles. That is wordy, but it's very simple. Let me show you what it's saying. It's saying in this picture, the measure of angle 1, our exterior angle, is literally equal to the sum of these two angles. So if you add angle 2 and angle 3 together, whatever their measures are, that will literally equal this outside one. So just make a note, it does not involve the interior angle that's right next to that exterior angle. This one always involves the two that are furthest from it. Okay, so over here I'm going to say the measure of angle 1 equals, and we'll go ahead and write the measure of angle 2 plus the measure of angle 3. And if you haven't ever written an angle symbol, it almost looks like a less than when you write it. I try to make it look like an angle symbol, but sometimes it just looks like less than, but it does mean angle. Measure of angle 2 plus measure of angle 3. All right, now the rest of these are just practice problems using those theorems. I will say 5 and 6 are a little bit more of a bonus round, so stick around for those if you do want to try them. But let's definitely cover 1, 2, and 3. So number 1, we're going to use the triangle angle sum theorem to answer it. So let's take a look at number 1. Gives you a triangle, and it tells you one angle is 24 degrees, the other angle is 37 degrees, and they just put a 1 on this one. It's not saying that's 1 degree. Obviously, that's a larger angle, but they're labeling it angle 1. And it wants you to find the measure of angle 1. So think about it. We just learned that if we add this angle plus this angle plus this angle, it all has to add up to 180 degrees. So the best way to do this would be add up the two that they give you. So let's do 24 degrees plus 37 degrees. What's that going to give us? 24 plus 37, we get 61 degrees. Okay, so we have a total of 61 degrees so far. So between those two and this third one, they have to add to 180. Easiest way to do that from here is take 180 degrees and subtract off the 61 degrees we already have. So let's do that. 180 minus 61, and that's going to give us our leftover angle, which is 119 degrees, which I might as well just put that right there for our answer. Perfect. So easiest way, if they give you two angles and you have to find the third one, just add those up and subtract from 180. All right. Number 2, now I noticed right away they draw an exterior angle, so I'm probably going to use that theorem. And this one's very straightforward. It's just like the example one we had above here. So if I want to find this exterior angle and they give me these two interior angles, I simply add them together. So I'm just doing 76 degrees plus 52 degrees. I guess I could put my degree symbols, I'm being lazy, but let's do that. What is 76 plus 52? That is going to give us our answer. So that gives us 128 degrees. And that would be this exterior angle. Okay, so those were pretty straightforward. Number 3 is a little bit tricky. You kind of have to think of a little backwards way to do this. There's a couple ways you could do this. So I challenge you to try it on your own. You might already kind of figure it out in your head. So it's an exterior angle problem. And you could think, well, if I add this angle plus this angle, if I add those together, I know they equal this one. You could actually write out like a little algebraic equation. There is an easier way to do it, but let's do that. And I'm going to call this angle 1, I'm going to give it a name like x. Let's say that's our x. This looks like an x, so I'm going to get rid of that. So I know if I take x, that angle, and I add it to 79 degrees, that's going to equal that exterior angle of 104. And look, you have made a nice little equation, and you can just solve for x now. So we would subtract 79 from both sides, which you might have made that connection in your head, like, oh, I can just subtract 79 from 104 and get my answer. But this is one way you could set up a little equation and solve it to get your answer. So we get x equals whatever 104 minus 79 is, which is going to give us 25. And that would be our little missing angle measure for angle 1. So I would put 25 degrees. Put the degree symbol on it because my answer is an angle. All right, you ready for the bonus round? If you're not, go to the practice sheet. If you're ready, if you think you can handle the bonus, let's do it. It's not that bad. I think you can handle it. 5 and 6 are very similar, so if you want to go through 5 and then try 6 on your own, I highly recommend it. All right, let's dive in. So number 5. It says solve for x, then find each angle measure. Yeah, if you look to the side here, it does want you to solve for x, and then it wants you to actually find the measure of the 3 angles. That part's actually surprisingly easy. Let's see if we can find x first. So this looks kind of crazy. Now, anytime you have a problem like this, where they do label something for all of the 3 angles, they don't tell you what any of the angles are, but they do have something labeled for each of them, like a little algebraic expression. Well, think about what you know about those angles. You know that all 3 added together equals 180 degrees every single time. So why don't we set up an equation where we express just that? We do this plus this plus this. That'll be a lot, but we'll do that, add those, and put equals 180. And that's going to be our setup. So let's do it. Start with writing this one. And you know what? If you're just adding a bunch of things together, you don't really need the parentheses anymore. So I'm going to drop the parentheses and just say, okay, 9x plus 3 plus my next one. And it doesn't matter the order that you go in, just whatever order you want. Plus 5x minus 2 plus my third one, 11x minus 21. Just line them all up, add them all together. I'm going to set all that equal to 180 because my theorem tells me that is accurate and I can do that. That is the geometry part, the setup. The rest of it's algebra. Okay, so now you're just going to simplify this whole side here. Okay, so look for your like terms, right? We have 9x, 5x, 11x. We can add together. What's that going to give us? 25x. Yeah, 25x, okay. And then you've also got 3 minus 2, which would be just 1, minus 21, which is going to give us negative 20. So minus 20. So just careful with combining like terms right there. All equals 180, and now super easy to solve. Go ahead and add that 20 to both sides. We've done lots of solving at this point. You should be solid here. Bring down our 25x equals 200. Divide both sides by 25. Divide by 25. And we get x equals, what is that, 8? Yeah, okay. x equals 8. We did it. Not too bad on the solving part. So we can go over here and answer the hardest question, which is the value of x. X equals 8. We're done there. Now, it's going to ask you these follow-up questions, but all you have to do is take your value that you got for x and go plug them in for all of the x's to actually solve for their angles. So for instance, if I want to find the measure of angle D, let's do that one first. I'm going to zoom in here. Angle D is right here. I'm going to take my 8 that I just got for x and plug it in right here. So I'm basically going to do, let's do it over here. I'm going to do 5 times 8 minus 2. Okay, so what's that going to give me? 5 times 8, that gives us 40 minus 2. We get 38 degrees for angle D. And it's that simple, 38 degrees. Okay, see if you can do the rest of them. So the measure of angle E is next. Let's look at that. Measure of angle E. So see if you can do that one on your own and then check your work with me. But we're gonna plug in 8 right here for x. And you can start kind of doing these in your head. You can be like, okay, 9 times 8, I get 72. Add 3 to that. So it's gonna give me 75 degrees for this angle. Okay, so I'm gonna go over here. E is 75 degrees. And then our last one, measure of angle F. Now I will say you could go about this one of two ways. Now that you know 2 of the angles of the triangle, and you know they all add to 180, you could just add up these 2 and subtract from 180. You know what, I'm gonna do that actually. Let's do 38 plus 75. We get 113, and we're gonna do 180 minus 113 to give us our last angle, which I'm getting 67 degrees. Okay, I think that's a little bit easier, but if you want, or if you didn't recognize that for a measure of angle F, you can do the same thing. Plug in the 8 for x right here. So you're doing 11 times 8, which is 88, minus 21, which you'd still get 67 degrees. So you still get the same answer regardless. Okay, we are on our very last problem, if you're still with me. So feel free to try this one on your own. Otherwise, we're gonna go through this one pretty quickly. It's very similar to the one we just did. They give you an expression for all 3 angles. So I'm gonna add them all together, set them equal to 180. Start with this one. 4x minus 22 plus 10x minus 4 plus x plus 11. We add them up, we set equal to 180. And now it's just algebra, so now we solve. Let's see, we got a 4x, a 10x, and a 1x. That's gonna give me 15x. Okay, and then we've got a negative 22, careful with your negatives, a negative 4, which is gonna give me negative 26, and then I've got negative 26 plus 11, okay? So it's gonna give me, let's see, negative 26 plus 11, so that'd be negative 15 equals 180. Okay, let's keep solving from there. So now we're gonna add our 15 to both sides, obviously. You guys have done a million problems like this now. So we get 195, and then divide by 15 on both sides. We get x equals, let's see, 195 divided by 15, goes in evenly, we get x equals 13. Not too bad. I know we went through that quickly, but I'm hoping you guys tried it on your own and you're just checking your work with me at this point. Okay, x equals 13. Now we go plug it in to solve all of our angles. So let's find the measure of angle P first. Let's see, we're plugging in 13 in for x right here. So I know, oops. Okay, I don't know what I did there. I just moved that. Let's exit out of that. There we go. Okay, let's plug in our 13 for x for this one. So we do 10 times 13 minus 4. So 10 times 13, obviously that's 130. Subtract 4, we get 126 for angle P. 126 degrees. Okay, let's try a measure of angle Q. over here. So we're going to plug 13 in for x right here. Okay, so let's go 4 times 13. That gives us 52. Subtracting 22, we get 30 degrees for angle Q. 30 degrees. Okay, and then we have one angle left. I'm going to do my shortcut method where I add these two together and subtract from 180. I think that's just the easiest. 126 plus 30 is going to give us 156. And then if we do 180 minus that, that's going to leave us with 24 degrees. And that would be final answer. Okay, you've learned a lot about triangles now. You guys did really good. Hopefully you followed all that. I know that was a little overwhelming, but I will see you in the practice video now. Good luck, y'all.